Hello students, in today's video class, we are going to discuss a program related with method recursion. And the question is, write a Java program to take two integer numbers as input and display their least common multiple, okay, or we can say lowest common multiple, okay. Use the method recursion technique. Okay. Now, let us take an example. Suppose least common multiple of 2 and 3. Least common multiple of 2 and 3. Now, there are two ways to find the least common multiple of 2 and 3. There is first approach and second approach. We will be following another approach. Let me tell you both the approach. One approach of finding the LCM in mathematics is just write 2 into 3. Since both are prime numbers, multiplication is their LCM. But if I go step by step, 2 ones are 2. 2 cannot divide 3. So just write 3. Then 3. Just write 1 here and 3 ones are 3. So what is LCM? The LCM is least common multiple is equal to 2 into 3. That is equal to 6. Okay. Or if you will tell that what is the least common multiple of 42 and 54. 42 and 54. See, 2 twos are 4, 2 ones are 2, 2 twos are 4, 2 sevens are 14. Okay. 3 sevens are 21, 3 nines are 27. Then 3 cannot divide 7, just write 7. 3 threes are 9. Then 3 cannot divide 7, just write 7. 3 ones are 3. And then write 7 ones are 7. Okay. So what is least common multiple? Least common multiple of 42 and 54 is equal to 2 into 3 into 3 into 3 into 7. That is equal to 3 twos are 6, 6 threes are 18 and 7 threes are 21. So 18 into 21, 18 into 21, 1 eights are 8, 1 ones are 1, 8 twos are 16, 2 ones are 2, 3. So 8, 7, 3, 378. Okay, 378 is the least common multiple of 42 and 54. Okay, but while writing the program, we will not follow this approach. Okay, there is another approach of understanding the least common multiple. See, multiples of 2. Okay, another approach, multiples of 2. Okay, if I have to find the least common multiple of 2 and 3, now what is the way? Another way. Multiples of 2 are 2 ones are 2, 2 twos are 4, 6, 8, 10, 12, 14, 16, 18, and 20. Okay, and multiples of 3 are 3 ones are 3, 3 twos are 6, 3 threes are 9, 3 fours are 12, 3 fives are 15, 3 sixes are 18, 3 sevens are 21, 3 eights are 24, 3 nines are 27, 3 tens are 30, and multiples are infinite. Okay, multiples are infinite. Now, let us see the common multiples of 2 and 3. See, the common multiples are 6. Here also we have 6. Here we have 12. Here also we have 12. Here we have 18 and here also we have 18. Clear, na? So the list of common multiples are also infinite. Okay, common multiples of 2 and 3 are common multiples of 2 and 3 are 6. Okay, 12, 18, and it will go to infinite. Okay, because multiples are infinite, so the common multiples will also be infinite. Now, what is the lowest common multiple? It is 6. Okay, lowest, or you can say least common multiple is equal to 6. Yes or no? So we will follow this approach in programming. Clear, na? Now let us discuss the second one and try to think it programmatically. Okay, try to think it programmatically. Listen. See, the multiples of 2 are the multiples of 2 are 2 ones are 2, 2 twos are 4, 2 threes are 6, 2 fours are 8, 2 fives are 10, 2 sixes are 12, 2 sevens are 14, 2 eights are 16, 2 nines are 18, and 2 tens are 20. Okay, and multiples of 3 are 3 ones are 3, 3 twos are 6, 3 threes are 9, 3 fours are 12, 3 fives are 15, 3 sixes are 18, 3 sevens are 21, 3 eights are 24, 3 nines are 27, and 3 tens are 30. 3 tens are 30. Clear? Okay. Now listen. See, the least common multiple of 2 and 3, we know the least common multiple of 2 and 3 is equal to 6. Clear, na? Now 6 is greater than the greater out of 2 and 3. Now in between 2 and 3, which one is greater? 3. So the chance is there, if there are two integer numbers, the least common multiple can either be the greater number itself or any number which is greater than the greater number. मैं क्या समझाने की कोशिश कर रहा हूं कि हमारे पास कोई भी दो इंटीजर वैल्यूज हैं, मान लो 2 और 3, तो 2 और 3 का मल्टीपल यहां पे कितना आ रहा है? 6 आ रहा है. ठीक है, तो 6 जो है ये 2 और 3 में से, ये दोनों में से बड़ा कौन सा है? 3 बड़ा है. ठीक है, तो मेरा कहने का मतलब ये है कि लीस्ट कॉमन मल्टीपल जब भी निकलेगा, या तो वो ये दो नंबर से जो ग्रेटर होगा उससे बराबर होगा, या फिर इससे ग्रेटर होगा. For example, the least common multiple of 3 and 6. For example, the least common multiple of 3 and 6 is equal to 6. है ना? तो 3 और 6 में least common multiple क्या है? 6 है, जो कि वो नंबर खुद है. लेकिन कौन सा नंबर? जो वो दोनों नंबर में से बड़ा है. इसलिए मैं कह रहा हूं कि ये दो नंबर जो हैं उसमें से ग्रेटर नंबर को हम लोग एक वेरिएबल में स्टोर कर लेंगे. ठीक है, ग्रेटर नंबर. ओके, वी विल गिव द नेम ग्रेटर नंबर. देन यू कैन सी द चांस इज देयर दैट द ग्रेटर नंबर कैनॉट बी may not be the least common multiple of the two numbers. For example, in this case, the greater out of 2 and 3 is 3, but 3 is not the least common multiple of 2 and 3. So what we will do, we will just increase the value of that greater value variable. What is the gap value between 3 and 6? The gap value is 3. Here, what is the gap value between 6 and 9? The gap value is 3. What is the gap value between 9 and 12? The gap value is 3. So in between the consecutive numbers in the list of multiples, the gap value is 3. The gap value is 3. The gap value between 24 and 27 is 3. The gap value between 27 and 30 is 3. So we will declare or use another variable and name it as what? Name it as fixed value. Name it as fixed value. Okay, name it as fixed value. Okay, we will name it as fixed value. So we will use one variable int greater value. Okay, greater value. Clear? We will use another variable called as a smaller value. Okay, and we will use one more variable, fixed value. Now where these variables will be declared, that is another part, but as of now I can say that I will be using these variables. One is greater value, The second one is a smaller value, and the third one is fixed value. The third one is fixed value. Clear? Okay. Now listen. Now how to do this? Let me directly write the program for you. Okay. Listen. Suppose there is a method, okay? Well, let me define the classes. Public. Let me import it. Import the scanner class. Import java.util.scanner. Import java.util.scanner. Public class least common multiple finder. Least common multiple finder. Okay. Now, here what I will do, I will declare a variable int fixed value. Okay. Fixed value. Okay. And assign 0. If I will not assign 0, then also it's okay, because JVM assigns the default value to the static variables. Let me make it static. Let me make it static value. Now, why am I declaring this variable as a static variable? I will tell, okay, you will understand, don't worry. Okay. So static int fixed value, and let me declare another variable static int CTR. CTR will be the counter variable. Now, what is the use of this variable? I will tell, don't worry. And let me assign 0. See, assigning 0 is not compulsory to the static variables, because we know that if the programmer is not initializing the static variables with any value, JVM supplies the static and non-static variables with default values according to their data type. But I am just initializing it, okay? Now, let me define which method? Main method. Public static void main capital S string string array space args. String array space args. Here, let me create the object of scanner. Scanner SCN is equal to new scanner. Scanner SCN is equal to new scanner system dot in. System dot in. System dot out dot println. Enter 2 integer values. Enter 2 integer values. Okay. Int n1 is equal to scanner object dot next int. Int n2 is equal to scanner object dot next int. Okay. Now, let me declare a variable with name LCM and call the recursive method get LCM. Okay, and pass the first and second integer values and display them. System.out.println least common multiple of concatenation sign n1, concatenation sign and concatenation sign n2 is equal to concatenation sign least common multiple. Least common multiple. Okay. Now let me define the get LCM method. Let me define the get LCM method. Public static int. Now why int? Why not void? Because here you are expecting a value from the method, and recursive methods are what? Their return type is apart from void. Okay. So public static int get LCM. Generally, I'm talking about general case, because as of now or till today, the programs which we have discussed, the return type of all the recursive method is apart from void. Yes or no? Okay, so public static int get LCM. Public static int get LCM and declare two parameters n1 and n2. N1 and n2. Clear? Okay. Just within the method, do one thing. Increase the value of CTR plus plus. Okay. Now, why am I doing CTR plus plus? I will discuss. But now you have got the answer of why have I declared CTR variable as a static. Because I need these variables within this method get LCM. And I want these two variables act as a global variable. Actually, in Java programming, there is nothing like global variable. But since the static variables accessibility is within all the methods, so we can consider static variables as global variables. So as I wanted the variables fixed value and CTR to access in getLCM method, okay, because I wanted their initial value to be 0, and then here I will modify their value, because here I cannot make them CTR is equal to 0, because every time this method will call itself, again and again the value of CTR will become 0, and I don't want it. That is the reason why I have declared CTR variable as a global, or you can say static variable. Clear, na? Because I want the updated value of CTR and updated value of fixed value variable. Clear? You will get to know, don't worry. So public static int get LCM n1 comma n2 int n2 CTR plus plus. Okay. Now let me write if CTR is equal to 1. So what is fixed value? What is fixed value? Fixed value should be the greater value. Okay. Just write here, fixed value is equal to the greater out of n1 and n2. How to get the greater out of n1 and n2? n1 greater than n2, use the ternary operator. So the value of n1 will get initialized to the variable fixed value, or else the value of n2 will get initialized to the variable fixed value. Clear? Clear, na? I have not given curly bracket because there is only one statement within the body of this if, where the condition is CTR is equal to. It means this statement will be executed only once, because this statement is written under a condition where the condition is CTR is equal to. And at the very first instance, when the method get LCM method will be called for the first time, CTR value will increase by 1. Yes or no? So its initial value was 0. So 0 plus plus means 1. After that, this line will never execute. Okay. Once this line executes, after that, it will never execute. That is the reason why I have used a counter variable. And since I do not want to make CTR 0 and 0 again and again, I have declared it as a static variable so that it can act as a global variable. Clear? Okay. Now, let me declare a variable called as greater value. Okay, int greater value. So greater value, the greater out of n1 and n2. Clear? So int greater value is equal to n1 greater than n2, n1 or else n2 or else n2. Int smaller value. Int smaller value. So we need it. I will show you. Listen now. n1 less than n2. So n1 will be initialized to smaller value, or else n2 will be initialized to smaller value. Clear? Okay. Now what I will do, I will just check whether the greater value modulus the first number is equal to 0, as well as the same greater value modulus n2 is equal to 0. Okay. So we need to return the greater value. We need to return the greater value. We need to return the greater value. Yes or no? See here. The least common multiple of 2 and 3 is 6. Okay. So what we are doing here, the greater value is what? See, n1 is 2 and n2 is 3. Now, which one is the greater value? Int greater value is equal to n1 greater than n2, n1 or else n2. Now, n1 greater than n2, what is n1? 2. 2 is greater than 3, it is false. If it is false, the value of n2 will get initialized to greater value. So, what will be greater value now? What will be greater value now? Greater value will be 3. Clear? Now, int smaller value. Int smaller value. So, smaller value is equal to what? N1 less than N2. So, N1 or else N2 or else N2. So, N1 less than N2. What is N1? It is 2. What is N2? It is 3. So, 2 is less than 3. Yes. So, the value of N1 will get initialized to the variable smaller value. Okay. Smaller value is equal to what? N1. What is the value of N1? It is 2. Clear na? Now, what am I checking here? That 3 modulus n1. 3 is the greater value. Yes or no? 3 is the greater value. So, 3 modulus n1 should be 0 as well as, okay, as well as means logical and. This greater value 3 modulus n2 should be equal to 0. Now, 3 modulus n1. What is the meaning of 3 modulus n1? 3 modulus n1. What is n1? It is 2. 3 modulus 2 is equal to 0. Is equal to 0. So, here we will get what? Here we will get false. Okay. So, here we are getting false. So, if we are getting false here, so the greater value will not be returned. The else part will be executed. Okay. The else part will be executed. And in the else part, I need to write what? The recursive case. So, I need to call the get LCM method again. But while calling the get LCM method again, I need to pass two things. I need to pass two things. Now, why? Because this get LCM method is a parameterized method having two parameters, n1 and n2 of type int. Now, in the second time, what do we need to pass? We need to pass what? Two things. One is, look here. One is we will pass the smaller value, that is 2. Yes or no? We will pass n1 as 2, the smaller value, and n2, it will be 3 plus 3. It will be 3 plus 3. Now, what is 3 now? 3 is the greater value. 3 is the greater value. And what is this 3? This 3 we can generate or we can get from fixed value. Clear? So, 3 plus 3, that is equal to 6 will be passed. So, second time, the values for n1 and n2 will be 2 and 6. Which one is greater? 6 is greater. So, 6 modulus 2 is equal to 0? Yes. 6 modulus 6 is equal to 0? Yes. Clear, na? Okay. Clear? Now listen. So, we will pass the greater value. Okay, we will pass the greater value. No, not greater value. First of all, smaller value. Okay, smaller value. And second, we will pass the greater value plus the fixed value. Greater value plus fixed value. Greater value plus fixed value. Okay, greater value plus fixed value. That is the reason why I have used this fixed value. Because in case of 2 and 3, the fixed value is 3. Yes or no? Because 3 is the greater one, 3 is the fixed value, 3 plus 3 is 6, 6 plus 3 9, 9 plus 3 12. Okay. Now, let me check whether this program is, I will do the dry run, don't worry. Okay. You will understand everything. Just keep patience. Listen. Control A, backspace. Okay. import import java dot util dot scanner scanner public public class LCM finder LCM finder public public static static. We need to declare two variables, static int fixed fixed value is equal to 0 and static is static int ctr is equal to 0. Public static void main capital str ing string array space args scanner scn equals to new scanner system.in system.out.println enter two integer values, int n1 is equal to scanner object dot next int. Okay, int n2 is equal to scanner object dot next int. Okay, and then int get LCM and just pass n1 and n2. Okay, and display it, not int get LCM, sorry, int LCM is equal to get LCM. Yes, it's correct. System.out.println the least common multiple of concatenation sign n1 concatenation sign and concatenation sign n2 concatenation sign is equal to concatenation sign least common multiple. Okay, public static static int get LCM. Okay, int n1 comma int n2. Okay, now this will be the recursive method. Now ctr plus plus. Okay, see, if ctr is equal to 1, then only I will assign fixed fixed value is equal to the greater value of out of n1 and n2. n1 greater than n2. Okay, so n1 will be initialized or else n2 will be initialized. Clear? Now listen, int greater value is equal to n1 greater than n2. Okay, so n1 will be initialized or else, sorry, it's n1 will be initialized or else n2 will be initialized. Then int smaller smaller value is equal to n1 less than n2. Okay, so n1 will be initialized or else n2 will be initialized. Clear? Now what we will do, we will just check whether greater value modulus n1 is equal to 0 and greater value modulus n2 is equal to 0. Okay, so return that greater value. Because see, because in case of 3 and 6, what is the least common multiple? 6, and 6 is the greater out of 3 and 6 only. So if greater value modulus first number and greater value modulus second number is equal to 0, that means that greater value is itself the LCM of the two numbers. Yes or no? So this is the what? Base case. This is the base case. Now what is the recursive case? Recursive case is you need to call the get LCM method again. Okay, get LCM method again. But think, the next time you need to pass two things. One, the smaller value. Okay, and second, greater value plus the step value or fixed value. Clear, na? So I will write here greater value plus FIXED, fixed value, greater value plus fixed value. Okay, greater value plus fixed value. So the result of greater value plus fixed value will be passed as the second argument. So a smaller value will be passed as the first argument. It will be received by the parameter n1, and the sum of greater value and fixed value will be passed as the argument, and it will be received by the second parameter, that is n2 of the get LCM method. Clear? Now close the block of get LCM method, close the block of main method, control shift I. No, control the block of class. Yes, this is the block of class, this is the block of get LCM method. Yes, correct. Now let me check, compile, no syntax error. Okay, close, right click, main method, okay, enter two integer number, suppose 2 and 3. See, the least common multiple of 2 and 3 is equal to 6. Now let me check for what the numbers were for 12 and 54. 12 and 54. So least common multiple is 108, 12 and 54. Okay, 12 and 54. Okay, 12 and 54. 12 and 54. 2 6s are 12, 2 2s are 4, 2 7s are 14. 2 3s are 6, 27 is not divisible. 3 1s are 3, 3 9s are 27. 1 3 3s are 9. 3 1s are 3. So least common multiple of 12 and 54 is equal to 2 into 2 into 3 into 3 into 3. That is equal to 2 2s are 4, 4 3s are 12, 12 3s are 36, 36 into 3, 36 into 3, 6 3s are 18, 3 3s are 9, then 108. Yes, the answer is correct. Okay, the output is correct, 108. Clear? Now let me pass this value. Which value? 42 and 54, and check whether 378 is coming or not. 42 and 54. Okay, 42 and 54. 42 and 54. 42 and 54. 378. Yes, 378. So the program is working fine. Now let me show you how this method is working. Okay, listen. Listen. Huh? Very, very important. Listen. So what was the method? The recursive method was public static int get LCM. Public static int get LCM int n1 and int n2. Okay, int n1 and int n2. Now, just remember the two static variables were what? Fixed value and CTR. Okay, just remember that. Static int fixed value is equal to 0 and static int CTR is equal to 0. So let me write these two variables. Here only. Fixed value, the value of this variable is 0 and CTR is 0. So these two variables will act as global variable. I mean, we can access these variables within the get LCM method. Clear? Now here the first line was CTR plus. Okay, and then we were checking CTR. If CTR is equal to 1, okay, then fixed value is equal to the greater value, n1 greater than n2. Okay, so n1 will be initialized, or else n2 will be initialized, Then we were declaring two variables, int greater value. Okay, int greater value is equal to n1 greater than n2, n1 or else n2. Then int smaller value. So a smaller value is equal to n1 less than n2, n1 or else n2. Clear? Now what we were checking, if greater value modulus n1 is equal to 0 and greater value modulus n2 is equal to 0. Okay, so we were returning greater value. Return greater value. Return greater value. Okay, so this was the base case. Okay, else return what? Else return, we were calling the same method. Get LCM. What? N, not n1. It will be smaller value. Smaller value, comma, greater value plus fixed value. Greater value plus fixed value. Or step value, you can say. Greater value plus fixed value or step value. Okay. Close the block of this method. Now try to understand. Very, very interesting and important also. See, if n1 is equal to 3, okay, and if n2 is equal to 2, CTR plus plus. What is CTR? CTR will become 1. CTR will become 1. Now, we are checking. CTR is equal to 1? Yes. So, fixed value is equal to n1 greater than n2. What is n1 greater than n2? n1 is 3, which is greater than 2. Yes, it's correct. So, n1, the value of n1 got initialized to fixed value. So, what is the value of n1? What is the value of n1 here? The value of n1 is 3. And what is the value of n2? n2 is 2. Okay. Now, what is fixed value? Fixed value is a global variable. We can say static variable. So n1, the value of n1 is getting initialized to the variable fixed value. So 3 is getting initialized. This is what we needed, yes or no? Okay. Now listen, int greater value. No doubt in greater value we will have. So I'm writing just GV. GV means greater value. Okay. So greater value is, no doubt, 3. Because here we are checking n1 greater than n2. And smaller value, let me write SB. Okay, smaller value. Now the smaller out of 3 and 2 is 2. So 2 will be initialized in smaller value. Now we are checking greater value, whether the greater value. Okay, what is greater value now? Greater value is 3. Greater value is 3. 3 modulus n1. What is n1? It is 3. 3 modulus 3 is equal to 0. So we are getting true. Now greater value 3. 3 modulus n2. What is n2? 2 is equal to 0. Now here we are getting false, and we have used logical AND. So if any one operand is false, the complete expression will return false. So this if part will not execute. I mean, this return greater value, this statement will not execute. The control will go to the else part, and in else part we have called the same method by passing the smaller value. What is the smaller value? The smaller value is 2 now. So we are passing 2, and then we are passing greater value plus fixed value. What is greater value? It is 3 plus fixed value is what? Fixed value is 3 only. You can see here, fixed value is 3. Greater value is 3, fixed value is 3. Okay, so 3 plus 3 is equal to 6. We are passing 2 and 6 to the same method. Now let me write the same method again, because this is method recursion where a method is calling itself. So its copy will be created. So public static int get LCM int n1 comma int n2. Okay, CTR plus plus. If CTR is equal to 1, fixed value is equal to n1 greater than n2 or else n1 or greater than n2, n1 or else n2. Yes. Int same thing, same coding. Int greater value. Int greater value is equal to n1 greater than n2. Okay, n1 or else n2 or else n2. Int smaller value. Int smaller value is equal to n1 less than n2 n1 or else n2 or else n2. Now here we will check if greater value modulus n1 is equal to 0 and greater value modulus n2 is equal to 0. So we have to return, this is the base case, this is the base case. We have to return what? The greater value. We have to return the greater value. Else return, this is the recursive case, call the same method, return get LCM and just pass two things, smaller value and greater value plus fixed value. Greater value plus fixed value. Greater value plus fixed value. Okay. Close the block of get LCM method. Now listen, what is happening here? Listen, see this 2, when you are calling the get LCM method, you are passing the smaller value whose value was 2. So 2 got passed to n1 parameter and this value 6 got passed to n2 parameter. Now n1 is 2 and n2 is 6. Okay. Now here n1 is 2 and n2 is 6. Now CTR plus plus. Now CTR was the static variable which was acting as the global variable. Now CTR plus plus, CTR will become 2. Okay. Now here 2 is equal to 1. So we will get false. If we get false, this statement won't execute. Clear now? Now you can understand why I have declared the variable CTR as a static variable which is acting as a global variable. Because if I had written CTR is equal to 0 within the same method, get LCM method, its value, the updation of the value of CTR would have not been possible. Yes or no? Okay, that is the reason why CTR variable was declared as a static variable so that it can act as a global variable. Clear? Because I want the modified value of CTR in every call. I want the modified value of CTR in every call. Now CTR value is 2, 2 is not equal to 1. So fixed value will remain same. Fixed value will remain same, that is 3. Now greater value, let me write GV only. Okay. Please excuse me, I'm writing GV. It should be greater value. Okay. So greater value n1 greater than n2. What is n1 now? It's 2. 2 is greater than 6. It's false. If it is false, then the value of n2 will get initialized to the variable greater value. So what is the value of n2? n2 is 6. 6 will be initialized to GV. Now a smaller value is equal to n1 less than n2. What is n1? It is 2. What is n1? It is 2. And what is n2? It is 6. Now 2 is less than 6? No. Okay. Oh, sorry. 2 is less than 6? Yes, 2 is less than 6. So n1, the value of n1 will get initialized to the smaller value. Okay. So SV, I'm writing SV for a smaller value. Okay, don't mind. So what is the smaller value? It is n1. What is n1? It is 2. Clear? Now greater value modulus n1 is equal to 0. Okay. Now what is greater value? Greater, what is written in the if condition? If greater value modulus n1 is equal to 0 and this condition, and GV modulus n2 is equal to 0. Now what is this one? GV is 6 modulus n1. What is n1? It is 2. 6 modulus 2 is equal to 0. So it is true. Okay, because 2, when it divides 6, the remainder is 0. And GV modulus n2, what is GV? It is 6 only. Modulus n2, what is n2? It is 6. 6 modulus 6 is equal to 0. So true. If both the operands are giving true, so the logical AND will give true as the final value. Now if it is true, return greater value. Return greater value. So return greater value. What is the greater value here? The greater value is 6. Okay, so 6 will be returned where? 6 will be returned here. Okay, 6 will be returned here. Clear? Now this is again returning that particular value. So this method will return the value 6 as the final result, And the main method, within the main method, that 6 is getting initialized to the variable LCM. Yes or no? See. Okay, within the main method, the 6, okay, is going from here and it is getting initialized to the variable LCM, and then we are displaying it. So this is how the recursive get LCM method is working. Okay, so you can take the screenshot of this. Okay, now take the screenshot of this also. Take the screenshot of this also, and take the screenshot of this. This is the dry run. Okay, this is the dry run. Clear? Okay, now listen. Take the screenshot of the program. First of all, take the screenshot of main method. Clear? Take it. Okay, and then take the screenshot of get LCM method. Clear? Okay, now so we can say, okay, we can say that this case, okay, this case is the base case, or you can say terminating case, base case or terminating case, and this case is the recursive case. This case is the recursive case. Clear? Clear, na? So thank you so much. Bye bye. Take care.